Okay, everybody, welcome to the first little piece of content that we have. This is just going to be a brief calculus review. We're just going to go over a little bit of the calculus concepts that you guys are going to need in order to succeed in this class. The way that I'm going to do this is on my iPad, so it is going to be a little shaky, but I'm going to try to keep it as smooth as possible. If for some reason we have to bail on this, I will make everything available that you see on the screen available to you and vice versa, whatever. It'll just be like we were in like a regular classroom at your fingertips. But yeah, and again, here's my email. If you guys need anything, please don't hesitate to reach out, all that good stuff. So yeah, here's a brief calculus rule. So first, we're just going to go over all of the calculus that we're going to ever need. So we have our very simple function, f of x is equal to c. This is just some constant function that is going to be pretty slopeless. And that's the big key here. Oh man, those are not very level. That's fine. And so, just kidding. Sorry, it has been a while since I have used this. Um, it is just going to have just a flat slope, and that's going to be our key thing, right? So if this is just at c, we have our f of x, and we have our x, then our derivative, f prime of x, is just going to be equal 0, right? So for example, this was f of x equals 2, then d dx of f of x should be equal to f prime of x, which should be equal to 0. Right, pretty straightforward, pretty simple. Everybody should know that one. The addition rule, also going to be pretty straightforward, pretty simple. So if we have this, then we are going to be taking our f prime of x, should just be equal to the derivatives of the two components in between, right? So if we have this as f of x is equal to 2x plus x squared, then we can just take this derivative of this first term plus this derivative of the second term to have our final solution. Again, this is now where the power rule comes into play. These are all in kind of abstract notation. There's not a lot of applications, but you can see the applications that we're going to do right below it. I think everybody gets the gist. This should be pretty straightforward as well. So the power rule, remember, we're just going to drop this x down in front, this n down in front, multiply it by the constant that was already out in front, and decrease n by 1. So if we had something like f of x is equal to 2 times x cubed, then f prime of x should equal 3 times 2 times x to the 3 minus 1, or 6x squared. Now, one of the things that we may get into when we're dealing with things like diminishing marginal returns or increasing marginal returns or whatever is we may have this n that is going to be less than 1. Or in other words, we may have something that looks, and we'll do this in pink so that we can kind of differentiate between the two examples. We may have something that looks like this, x to the 1/2. And if you notice that when we go to f prime of x, and we drop this 1/2 down in front, we get a negative 1/2 on top. So we get a minus sign in the exponent. Do not panic. The only thing that changes is that we just need to flip this minus sign underneath and make it positive, and we're good to go, right? Same thing happens that so this would be if n was greater than 0 but less than 1. If we wanted to do something super similar with n less than 0, where we would have c, or here, let's go, f of x should equal x to the minus 2, right? It works the exact same way. We're going to throw this minus 2 out in front, decrease this exponent by 1, and we can simplify this down if we want, but it's going to work the exact same way. So Just remember that your power rules can always work as long as we have x raised to some power. It doesn't have to be positive, doesn't have to be greater than 1. It can be less than 1. It can even be negative. If it's equal to 0, we know that x raised to the 0 power should just equal 1. And so it's going to reduce to something in the beginning that like we had dealt with before. Now, this is where we're going to start getting into something a little bit more complicated, the product rule. The product rule is pretty simple. We're going to take this first function, multiply it by the derivative of the second, and then we're going to take the second and multiply it by the derivative of the first. So there's going to be two components here that we really kind of have to deal with and remember. That's pretty much it. We're just going to hold one constant, let the other one change, hold the second one constant, let the first one change. So if we do for an example, let's say that we had like 2x times x squared, right? So in theory, we could have this just be 2x cubed, right? So we know that that should be 6x squared, right? But we can solve this the long way. We can take 2x times 2x plus x squared times 2, right? And so this is going to become 4x squared plus 2x squared, or 6x squared, like we said before. Similarly, we have the quotient rule, right? And so if we take f prime of x of the quotient rule, we're going to take the bottom function times the derivative of the top minus the top function times the derivative of the bottom, all over the bottom squared. Low d high minus high d low, all over low squared. And so if we have something like our same thing, let's say that we had x squared over x or something similar, right? This would reduce to just x. And so our f prime of x should be 1, right? If we use the quotient rule, we're going to take the bottom times the derivative of the top minus the top times the derivative of the bottom, all over the bottom squared. And so we're going to get 2x cubed minus x squared minus x squared over x squared, which should just be 1. Chain rule, we're going to take this derivative. We're going to take the derivative of the outside, leaving the inside as is, times the derivative of the inside, right? So if we had something like f of x should equal 2x squared, right? So we know that this would be just 4x squared, and so f prime of x would be 8x. We could use the chain rule, and we could say that f prime of x should be the derivative of the outside times the derivative of the inside, which would be 4x times 2, or 8x. The exponential rule, this is an e, right? And so f prime of x, when we have an e, is just going to be g prime of x times e to the g of x. Again, so if we had something like e to the x squared, again, we're not going to really need the e. Really, we're doing this so that we can do this for completeness. We're going to go f prime of x is equal to 2x times e to the x squared. All right, going to be pretty straightforward, pretty simple, all sorts of good stuff. This is why we're doing it for completeness, because we will use some logarithms. If we have this derivative, it's just simply 1 over gx times g prime of x. And so if we had something like f of x equals ln of x squared, f prime of x should be 1 over x squared times 2x, or 2 over x. Pretty simple, pretty straightforward. Should be just reminding you of calculus, all that good stuff. This is where we may get into a little bit of weirdness. So partial derivatives is something that we don't teach at the University of Wyoming for Calc 1. I think we teach it in Calc 2 or Calc 3. Partial derivatives are super, super easy. Partial derivatives are denoted by this. fancy little d instead of the straight d that we normally do. And this term in the bottom is what we're going to be differentiating with respect to. And so in this instance, we read this as we want the partial derivative of f of x with respect to x. And what that means is that we are just going to hold the other term constant. So imagine we just had this. This derivative with respect to with respect to x would be 2cx, right? That's the same content. Same idea, right? We're going to take this derivative and we are going to derive it holding y constant, and we're going to have 2y cubed x, right? Very similarly, if we go on the other side and we want to derive with respect to y, we are instead going to hold x constant. And so we are going to get 3y squared x squared. That's it. That's easy. That's the partial derivative. It's essentially like pretend it doesn't exist, multiply it in at the end, or however it's going to be involved in the end, and everything will be great. Okay, so that's the end of the calc review. That's all that I've got. If we have any questions on this stuff, especially the partial derivatives, please don't hesitate to reach out. This is going to be kind of fundamental to our tools. And if we need to know how to use our tools in order to be successful in this class. And so really just kind of let me know if you're struggling at all, and we will get going on the content in the next video.